Okay, good morning, everybody. I'm very excited to see that so many people dialed in today and that there's obviously such a broad interest in this topic in our work. We have a very packed agenda, so let's dive in directly. Today's topic is the technical battery passport system, especially regulatory requirements, technical challenges, and possible solutions. My name is Patrick. I'm one of the work package leads of the Battery Pass project on behalf of the Research Institute Fraunhofer IPK. And with me here today are a couple of technical experts from the Battery Pass Consortium. Those are Gerrit and Jason from the Fiverr Foundation, Nico and Kunrad from Circular, and we have Thomas in the call, who is the convener of the standardization request ad hoc group by Sensenelec. Not all of us will present here today and make you familiar with the technical challenges of a battery pass system, but everybody had a substantial contribution to the input you will see here today. Let's look at our agenda of today's webinar and how we plan to spend the next 1.5 hours. We will start with a brief introduction and overview on the Battery Pass project. Then we will learn what the battery passport is from a technical point of view according to the regulation. What are the technical requirements and what is our approach within our project? And after, we will have a deep dive into the technical challenges of the battery passport system, where I will hand over to some of our technical experts. We'll start with the challenge of interoperability, handing over to decentral data spaces, and then give you some insights to data models, data granularity, as well as supply chain diligence. The last 15 minutes will be reserved for the next steps. Those will be the next steps within our technical work stream of the project, as well as next steps in standardization and recommendation, how you as a part of the battery ecosystem could prepare yourselves. First, a couple of ground rules. As you might have already noticed, the meeting will be recorded for those of you who couldn't join us here today. Your videos are disabled to save bandwidth, as well as your microphones. They're all muted to not disturb the session. Feel free to use the chat. Due to technical limitations, the chat will only be available to those who are using the Microsoft Teams app. If you dial it in with your web browser, that functionality might not be available. It's quite full here today, and there are probably a lot of questions. Our technical experts are present in the chat and will try to answer some of your questions. However, we will collect all questions and incorporate them into our work where it makes sense to do so. Teams will offer you to raise your hands, but we won't have the time in our agenda today to react to that. I'm sorry for that. Important to know as well is that the Battery Pass project works in a pre-competitive field. That means that topics that are inadmissible under antitrust law may not be raised by the participants. Okay, let's continue with a brief introduction of the Battery Pass Consortium. We kicked off our work 1.5 years ago in April 2022 in Berlin. The consortium consists of 11 partners who represent the entire value stream. The project is led by Systemic. We have industrial companies like Audi, BASF, BMW, and Umicore. We have technology providers like Circular, the Fiverr Foundation, Twice. The research organization Acatech and Fraunhofer, as well as VDI Renewables as a subcontracting partner. The project is co-funded by the German Federal Ministry for Economic Affairs and Climate Action with around 8 million euros. And our goal is to provide guidance on the digital battery passport as mandated by the EU battery regulation. And that guidance includes the content, the technology, and the value assessment of the battery passport. And we will present those results in a combined demonstrator. Our time frame is 3 years, so there are another 1.5 in front of us. In April, we have released our first results at the Hanover Fair to the Ministry, and this is what we call the Battery Pass passport content guidance. The content guidance is the first comprehensive aggregation and interpretation of content reporting requirements as per EU battery regulation. And it allows battery value chain players to prepare for the battery passport implementation. Besides that report, we condensed those information into a slide deck as an executive summary, as well as a position paper directed at the European Commission. The data attribute long list includes all data attributes required and suggested for the battery passport alongside definitions as well as further relevant data dimensions. It can basically serve as a basis for passport implementations within your own organization. In addition, we released 2 carbon footprint specific reports, giving you deeper insights to carbon footprint rules and end-of-life analysis. All of those documents you can find on our website, free for you to download. Let's look at what the battery passport actually is according to the regulation. What are the technical requirements and what is our approach in the technical work stream of our project? A digital product passport, DPP in short, consists of 2 main pillars. That's the DPP data and the DPP system. The DPP data consists of attributes like description of materials, components or products, recycled content, substances of concern, environmental footprint, performance parameters, technical parameters, and so on and on. Those attributes are sector-specific and will be defined in sector-specific regulations. Battery regulation itself is where the content guidance is based on. It's the first of many more regulations to come in the future, such as electronics, textiles, and constructions. On the other hand, we have the DPP system, which is sector unspecific. It means we won't have a battery-specific DPP system. The same concept needs to work for all kinds of different product categories. All of those where a DPP will be mandatory in the future. So what we need are harmonized technical standards in order to build a technical DPP system that is independent from the sector. And that will be the focus of today's webinar. Two regulatory frameworks lay the groundwork for battery passports. That is the battery regulation and the eco-design for sustainable products regulation, ESPR. The battery regulation already went through trilogue negotiations between the European institutions, the Commission, the Parliament, and the Council, and went into force in August this year. Now the secondary legislation process started, where further details will be defined in upcoming delegated and implementing acts before the battery passport becomes mandatory in February 2027. Again, the battery regulation mainly focuses on the content of the battery passport, the DPP data. The overreaching regulation defining details about the overall DPP system is the ESPR. The proposal of the ESPR was adopted in March 2022, and we expect it to enter into force by the end of the year, before it will be adopted 42 months later in 2027 as well. Not less for us, less important for us is the standardization process around the ESPR. The standardization process will define the key technical aspects of how the DPP system will look like. And that process started in June with the kickoff of the CENELEC standardization request ad hoc group. The standardization request ad hoc group's role is to coordinate between all the relevant stakeholders and gather their input during the drafting and approval of the standardization request. We expect that the final standardization list will be published this month as well. And in January, the Joint Technical Committee, number 24 to be precise, will start their work. Within 24 months, the JTC will develop harmonized standards that will be the foundation of the DPP system. So let's talk a little bit about the battery passport system and what we know about it according to the regulation. The battery passport itself is an electronic record for batteries which shall contain information relating to the battery model and information specific to the individual battery. Or in other words, the battery pass is a structured collection of product-related data with predefined scope and agreed data ownership and access rights conveyed through a unique identifier. But before we can even think about publishing a digital product passport, we need to have the data in place. That data is coming from the upstream processes, starting with mining and refining, till the production and assembly of the battery. But as well the downstream, with dynamic and static data coming from the usage phase, as well as repurposing, reuse, remanufacturing, and recycling. Responsible for the collection and processing of this battery passport information is the economic operator who places the battery on the market. Of course, the data needs to be exchanged somehow along the value stream. The regulation refers to the requirement of an interoperable exchange network, which shouldn't lead to a vendor lock-in, but pave the way. But the way or technology of data collection and processing is not further specified in the regulation. Of course, there are already supported systems available today, like traceability systems, who could handle such a data exchange, but more to that a little later in this webinar. Data processing and storage. The battery passport should be based on a decentralized data system set up and maintained by economic operators. That means every economic operator itself is responsible to provide digital product passports with their own IT systems. While all the collection, processing, transferring happens on the backend system of the economic operator, we will talk about the digital passport data repository in the coming slides. The DPP data repository will be the specific system of the economic operator, which provides the structured collection of product-related data and agreed access rights. He doesn't necessarily need to have that system up and running on his own. Economic operators can authorize other operators to act on their behalf and store the data being accessible via the battery passport. How does the data access to a battery passport work? We will have a product passport registry. This registry will be set up and maintained by the European Commission and will store selected data of product passports. As of today, we know that at least identification data will be stored in that registry. The economic operator will be responsible for uploading the mandatory data to the registry, and it will at least be accessible to national authorities, custom authorities, and the Commission itself. So the registry is one way of accessing product passports. Another way is through data carriers. The data carrier, as by the ESPR, is a linear barcode symbol, a two-dimensional symbol, or other automatic identification data capture mediums that can be read by a device. So it's basically a link between the physical and the digital world. The data carrier stores a unique identifier of the battery passport. And by scanning the data carrier attached to your battery with a suited device, like a phone, you get access to the digital product passport. For battery, it's even further specified already. The battery regulation demands QR codes as a data carrier for battery passports, but leaves it open that other smart labels may be adapted in the future. The data of a battery passport is, of course, also subject to access rights with access to different sub-aspects of the passport. Here, the regulation has identified three groups. We have the general public, we have notified bodies, market surveillance authorities, and the Commission, as well as any natural or legal person with a legitimate interest in accessing and processing that information. Very important to know is when we speak about a DPP system, we're actually talking about the upper half of this picture. The whole data collection and exchange is necessary to be able to publish a battery passport, of course. And it's under the responsibility of the economic operator, but it's not further specified as DPP system requirements in the regulation. Okay, so our project started in April 2022. The technical work stream some months later, but still, the battery regulation was going through a trilogue. The ESPR is not even out yet, and so is the standardization request. So we needed to come up with our own technical backbone of building blocks we believe are necessary to bring a DPP system to life. And in order to do so, we made use of a framework for enterprise interoperability based on an ISO standard 113541, which set our scope and guided us. And the result you can see here on the left is what we call the technical standard stack. That stack represents the minimum of technical standards you need to build up and maintain an IT infrastructure, functionalities in form of software, as well as management and governance systems. For example, we already learned from the regulation that we need data carriers and unique identifiers. We believe we need data models as a structured representation of the passport data. We believe we need standardized protocols and data formats for the exchange of information. Data needs to be stored somehow and persistence needs to be assured. Identity and access management is a crucial pillar of the whole system. We need to have core services harmonized, like basic CRUD operations, create, read, update, delete of data. We need standardized processes like information flows, responsibilities, and rules. And we need a whole security infrastructure in place, ways to manage and enforce policies, as well as governance systems around it. As I said earlier, our goal is to provide guidance and feedback as a neutral player in the whole emerging world of battery passports. So we are very happy if we can contribute with our work to the upcoming standardization efforts. You can see on the left the categories that will most likely be the ones subject of the upcoming standardization request, like, for example, APIs for the lifecycle management and searchability of digital product passports, access right management, storage, persistent, and so on. And on the right, our standard stack. Besides contributing to the list on the left, we're pretty much aligned with our initial efforts. The categories marked with a star will be subject of upcoming directives in the future. And besides leaving those categories aside for today, we will focus on this webinar on the topics which have generated the most discussions within our consortium, which are identity and access management, as well as everything related to data. As you can see there in a black box on the picture. We, as a Battery Pass Consortium, we actually don't develop our own Battery Pass system solution ready for implementation. Instead, what we want is to identify standards along that standards that you just saw, which could help in doing so. And here we follow a top-down approach, starting on a global level, where we look for global standards set by ISO, IEC, for example, going down to the European level, CEN, CENELEC, ETSI. As a German project, we of course focus on our German standard organizations like DIN, DKE. But we also look into standard setting organizations, IATF, W3C, as well as associations like Gaia-X, the Global Battery Alliance, and Gaia-X, where we have strong ties within our project. And in order to identify suitable standards, we set ourselves evaluation criteria. Although we focus on batteries within our project focus, the DPP system will need to handle all kinds of product categories. So cross-sector suitability should be one of the criteria. We focus on open, non-proprietary standards. because all economic operators along the value chain must be given the possibility to create a DPP based on harmonized, open, and interoperable standards without depending on any commercial technology or service providers. We should enable coexistence of standards wherever possible. Unique identifiers, for example, if you have an existing legacy identification system in place, the DPP should be made interoperable with it. And we should take the requirements of all stakeholders into consideration, like the public, economic operators, or market surveillance, for example. What we need to identify are existing mature international standards, as well as new and innovative approaches. Again, here aligned with upcoming standardization requests. Before I will hand over to Gernot, who will give you our insights to decentralized data spaces and NICO to data models, granularity, and supply chain due diligence, let's talk about interoperability and why this is such a challenge for the DPP system. Let me give you some examples. You might remember the picture I showed you earlier. To access a battery passport, you're supposed to read a QR code, let's say with a smartphone, with a link that redirects you to the specific passport with the individual data. If you want more than the public available information, let's say you're part of an access group of recyclers, for example, we need to make sure you can provide an identity we can trust to prove that. We introduced earlier the wording DPP data repository. So we will have a decentralized system. That means it is up to the economic operator how the DPP data repository will look like. It's up to the economic operator if he wants to create his own database system, maybe an SQL-based database, or he could rely on solutions like the asset administration shell or based on NGS-ILD, all with their own APIs to access data. So what we need to make sure is that we have passport services or APIs in place in order to enable a harmonized way to access DPP data based on common specifications. That's even more important when we want to enable functionalities like searching or, for example, aggregated views for the market surveillance. What about a data carrier? If we encode an URL on the QR code, it sounds easy. So every modern smartphone basically can read it, you scan it, you get directed to the passport. But you need to be online. What about scenarios where you don't have internet access? Can you store offline information too? Storing an URL on a QR code is standardized. How do you make sure that you can still access DPP without the need of a dedicated app that needs to be developed and maintained? Or how much data can you store in the QR code anyway until it gets too big or the resolution becomes too high to print it on the product? What about other types of data carriers? Modern phones can read NFC text, for example, too, with URLs embedded in it. Data matrix codes, unfortunately not. If we decide to store URLs in data carrier to enable access without an app, how do we ensure that the data carrier stays up to date? What happens when the economic operator changes or ceases to exist? Maybe the registry could act as the resolver, so we only store unique links to the registry in the data carrier, and the registry redirects us to the DPP data repository. And that is only a small subset of questions that arise when you look at the DPP system more closely from a technical point of view. What we really need are common requirements in order to standardize how the DPP system will look like. And hopefully with more answers than questions, I will hand over to Gernot and Decentralized Data Spaces.
Yeah, thank you, Patrick. Also, a warm welcome from me to the audience that is still growing. Very appreciated and nice to see. Gernot Böge, Solution Architect from the Fiverr Foundation. we as a technology provider and also closely aligned to several data space and data economy initiatives are happy to support the project. And I want to talk about decentral data spaces and the implications of it. And as you might know, and you heard probably about these expressions, this is a quite extensive topic, and today it can just be a scratch on the surface. So probably there will be some questions open, but the project will last 1.5 years more. So hopefully we, and also in the standardization activities, will be able to answer all these questions afterwards. Good. I have to click. I want to guide you in 20 minutes around data spaces with a scenario to get an idea of the given complexity. And the scenario is a dismantler who prepares batteries for later recycling by a recycler. And they receive a truckload of batteries. And as you can see on the picture, there's a whole variety of different batteries. So you have to handle this. And these different batteries are not of different types, not only of different types, but they probably come from different countries, from different suppliers, economic operators. So it's a colorful load that you can see on the truck. And the employees need to dismantle, they need the dismantle information from the battery passport of each of the many batteries to help and to organize the processes for an efficient dismantling process. So the context and the requirements to situations, this situation is, Patrick already spoke about access groups, so we call them also stakeholder group. And in the whole system of the battery passport, he's an accredited dismantler. That's his role. And based on this stakeholder group, he should be able to see data. I mentioned before, batteries come from different economic operators, cross-country, cross-supplier, so very colorful. And the stakeholder group is the basis to manage the access to sensitive and restricted data, because not every data attribute that is available in the battery passport should be visible to everyone. That needs digital sovereignty on the economic operator system. One for the data provider, the economic operator, that the data he provides to the internet will be protected, and also for the dismantler, that he only provides the data that he needs to and wants to provide. There needs to be trust in claims about stakeholder groups, because if you provide data and it is access restricted, you should trust the mechanisms for access control. And it must be a fast and efficient process, because the amount of batteries is growing fast, and so the process must be efficient, that the business can be efficient. And the same processes and access control policies should be the same across all the different economic operators, and there can be hundreds and thousands of different economic operators, and he should not learn processes and steps and systems for each of them. So that's also in the requirement that processes are similar, or best case identical. So if we consider the usual trust and identity and policy mechanisms of today, are they sufficient to support this quite colorful ecosystem of dismantlers, recyclers, different economic operators in different countries? Are they sufficient to support such an ecosystem? And therefore, I just have grouped them in 3 different columns. And the first one is single documents. If you have a local business, you can ask someone to show your identity card. You can know who he is. In the digital world, this can be done with a digital certificate, like from EIDAS. And this is for identification. And if you want to see certificates, of course, you can handle some certificates in paper or in some pictures or screenshots, PDFs, whatever. In the digital world, spread at least across Europe, this is probably not an adequate solution. Classical identity management and identity providers as a second option. So identity management is a company hosts its own identity management solution, and identity provider is something you can see here, like, for example, login with Google or login with GitHub. So with big players or central players who offer identity and identity provision services. And normally you have to register, you have to be known, your access control mechanisms for this individual system, and the rules must be set up. So often you have options like email confirmation. You have to wait for the email and it goes to the spam folder, two-factor authentication, online verification, post ID, so many options. And if you consider this truck with the different, the big amount of batteries, probably this is not a viable solution. And a third group of mechanisms that we evaluated was member and club cards. For example, branded credit cards from the big credit card companies. There you have some special rights for insurances or for discounts at hotels, something like this. Yeah, might be an idea. And for example, if you think of discotheques and clubs, there is club VIP cards. So it's identity, who you are, and some policies, what you're allowed to do. Consider a club. This is more a regional thing, so it's difficult to roll this out to many different countries or companies, and so this is also a limited version. And those we have evaluated here are not a very perfect fit for the given complexity. But we have another one in the member and club cards category, so we call them airline frequent flyer cards, so miles and more, something like this. And I want to explain to you why this for us is a notable concept to learn from. We have a customer and an airline. The customer is frequently flying with the airline, and the airline checks the criteria whether a customer qualifies for a frequent flyer card. Then they issue a frequent flyer card and hand them over to the customer. He becomes the holder of this frequent flyer card and can go to an airport. And at the airport, he can present his frequent flyer card to some reception personnel or some clerks there, and they can verify and check the frequent flyer card and make decisions about access directly on the spot without talking to the airline, just by evaluating the frequent flyer card. And the decision can be, for example, you are eligible for accessing the fast lane in the security check, but you are not eligible for accessing the VIP lounge because your status is not high enough. So you have identity and you have some status that is somehow encoded in this frequent flyer card, and this can be taken as a verification mechanism to decide about your access to different areas or functionality at an airport. So this is also not digital because these are physical cards, and so we need an integrated digital framework. And in the technical standard stacks, this is in the decentralized data spaces, and we have the text in the regulatory documents to ensure that the battery passport is flexible, dynamic, and market-driven, and evolves in line with business models and markets and innovation. We need a decentralized data system. So it's not only solving problems of today, but it should be also possible to evolve over time to new arising and changing circumstances and conditions. And therefore, we can derive some battery passport requirements. What we need trust and digital sovereignty among the participants who often don't know each other. Because this dismantler we have seen in our scenario does probably not know 300-500 different economic operators who bring batteries to the market. So we need a trust and sovereignty mechanisms that they can trust each other even if they don't know each other. We need access rights policies to manage the criterion of stakeholder groups because this qualifies access to data. It should work cross-country and cross-company, of course. It should support fast and efficient processes for humans and machines, because it's not necessarily one battery after another, but there will probably also be some batch processes. It should be able to handle coexistence of standards, like Patrick described, for different identity mechanisms, for example. And it should not be a siloed single-purpose solution that you only build up for fulfilling the battery passport requirements. And we recommend to build the decentralized battery passport data system on the Gaia-X trust framework. We have received the question, why do not publish simply web pages for the battery passport? And in fact, we do. because if we deliver for an end customer who can see on the mobile, this is more or less a web page. But the reason for considering such a complex solution like Gaia-X trust framework, it's the reason of trust and sovereignty that needs to be created between participants in the system that do not know each other. A brief introduction to Gaia-X. Many probably have heard of them, but I guess not all. So it is a non-for-profit organization to boost the European data economy and get users in control of the data again. It should enable creation of common data spaces and is building on common open standards for transparent, controllable and interoperable data and infrastructures for trustworthy data exchange. So this already sounds like a solution, valid for evaluation. And the adoption, it is fully alignment with the European data strategy. It's adopted by the DSBA technical conversions discussion document, which is issued and set up by Gaia-X, the IDSA, FIWARE, and the BDVA organizations to bring the different existing data space standards together. As I mentioned, and as it's named, technical conversion, that they come together and are able to interoperate. And of course, probably you've heard of it, there are several lighthouse projects like Gaia-X, important in the automotive industry, but also in different domains like Gigant in manufacturing, X in mobility and tourism, and Structura-X. So it's already in implementation in several lighthouse projects. You can get quite a lot of information outside, and Gaia-X is especially important for us because it's automotive industry, and automotive with EV batteries is a big idea for us. Operations, there needs to be instances who run the core trust components. This can be done by the new acclaimed Gaia-X digital clearing houses. And for the tooling and the systems around, there's a growing international open source community from Gaia-X itself. They have a lab department from the Eclipse Foundation, FIWARE Foundation, and a big open source developer community. When we talk about Gaia-X, we talk about self-sovereign identities to increase trust and control, as those are the goals from the Gaia-X association. And then we talk in the technical standard stack about identity and access management. There are no individual regulatory requirements mentioned in the text, but the self-sovereign identity is a strong concept, not only for the battery pass. It provides digital, and this is important compared to the frequent flyer cards, digital identity credentials issued by verified parties in the system. So they are not by an airline like some company in the business, but there must be verified parties who are able to issue digital identity credentials that you can have the trust. It's based on advanced cryptographic signatures. It is enhancing the privacy because when you access a service, you must not connect to an identity provider. So, and also the issuer does not necessarily know that you are using this card. So it's enhancing the privacy. The issuer cannot collect data about the user anymore because there's no digital combination. So like with a central identity provider. And the holder has much more control over the data because he is asked, show me your card, and he can do so or not. So it's nothing happening in the background automatically. So both of the parties, the dismantler and also the provider of the battery passport data, have more control over the data. And therefore, we recommend to implement the concept of self-sovereign identities following the Gaia-X trust work because they are implementing it. Mentioned before, verifiable credentials to prove claims like who are you, identity, or what is your stakeholder roles, is implemented in the trust framework with verifiable credentials. It's in W3C standard, and it's touching in the technical standards 3 different categories: the identity and access management, policy management, and enforcement, and data protection, because based on these credentials, there should be decisions made. There are also no specific regulation texts indicated. And the verifiable credentials are the mechanism to implement the self-sovereign identities. They are digital credentials in a decentralized, secure manner. So you can have this identity and you can use it like the frequent flyer card in different places. So it's decentralized, and because of the cryptographical aspects, it's also a secure way. It represents exchange. It represents and exchange information about, for example, a person, an organization, or a thing in a digital format that can be cryptographically verified. And this verified is important because this is one of the core aspects of the security. So it's you as you have such a verifiable credential in your hand, you can verify whether it is really coming from the issuer that you expect it to be, and this done by mathematical cryptographical mechanisms. They will be issued and signed by a registered trust anchor, depending on the ecosystem. So the supply chain of batteries is quite international. So there can be trust anchors in Europe, but maybe also in African or South American production countries. They are tamper evident. They are available for a variety of purposes like proving identity, stakeholder group certifications. They are ready to handle eIDAS identities. This is important because eIDAS is an existing standard in Europe. So it's identifying companies, and it's there. We can use it in the system. We do not have to reinvent the wheel. And they are presented as not single verifiable credentials, but in verifiable presentations that are just bundling one or more verifiable credentials. It's a technical issue. They do not replace access or session token, and they can be bundled also with the well-adopted OpenID Connect technology. So it's something new, but you can combine it with something battle tested and well accepted. Good. And therefore, we recommend to implement the concept of verifiable credentials based on the Gaia-X trust framework. And this is the core concept. You have an issuer of verifiable credentials. He is issuing credentials like about your identity. So I have checked that you are this person, and I issue a digital proof of that. And you hand it over to the holder, and the holder can then present this digital token, this digital information to the verifier, and the verifier then can verify this information by going to a public available registry where the cryptographical information is available to verify that this is correct information. So this can be explained, of course, more detail, but someone issues information, provides information how to verify if it's correct. A credential is created, can be presented, a verifier can check it, and this check process does not necessarily involve the issuer itself, so he does not necessarily need to know about it. Good. This is a new way to enforce access control management. Here we are in identity and access management, policy management enforcement, and data protection sovereignty. There's also no specific text in the regulation. And for the requirements to control the data access for unknown customers in Battery Passport, we need, of course, policies expressed in a standard and machine-readable way. In Gaia-X, it is the W3C standard ODL, Open Digital Rights Language. It has to evaluate policies based on self-sovereign identity and verifiable credentials, because if I present you a credential for being the accredited dismantler, you should be granted access based on this information. The access rights policy go down to the attribute level. This is in the regulation because in some information groups, there are some data that are public and some other are not. We need an access delegation mechanism because in the regulation, there is a possibility that you can mandate data access also to service providers like owners of a garage, for example, who do car repair. There should be one single public access rights policy rule set for all participants, because the dismantler should be available, should be able to access data at, like on the truck, several hundred different economic operators, battery passport systems. And of course, it should also be considering usage control obligations, because it's not only about accessing data, but also that what you do with it, because if you have access data, you should not sell the data, for example. There should be obligations too. And therefore, we, as you probably have guessed, we recommend to implement the concept of access and usage control policies following the Gaia-X trust framework. And the Gaia-X association itself does not provide, they have a lab for proving technology, but tools for implementing such access control management will be provided as open source and commercial tools by external contributors. Fiverr is working on a connector, Eclipse Foundation, the IDTA. They are all working on mechanisms like that. Good. Ensure interoperability among digital product passports, DPP, and other data space initiatives. This is what Patrick mentioned before. It should not be for batteries. It should be also for the other sectors of battery passports. And to be interoperable, you have to have some base rules. And here, this is the Gaia-X compliance rules in blue. This is necessary to be Gaia-X compliant, that the mechanism of data spaces within with the Gaia-X trust framework works. But of course, you have some domain-specific rules that must be added. And we in Battery Passport would be one Gaia-X-based ecosystem among others, like, for example, with Gaia-X, Catena-X, or the other I mentioned before. And here's some known Battery Passport specifics. We will probably have no individual contract negotiations. This differs a bit from standard procedures in Gaia-X. We will have individual stakeholder groups that are probably not interesting in domains like tourism or other. So there will be individual extensions, and there will probably be individual trust anchors, also sector specific for the Battery Passport. Similar but different, but all based on the same ground rules, the Gaia-X compliance rules. So our scenario implemented with the Gaia-X trust framework, a little bit simplified. We have the business passport, Battery Passport stakeholder. It's the accredited dismantler, and we have the trust anchor that is a trusted authority or a trusted company in the ecosystem. They become the issuer of verifiable credentials. He has to, the trust anchor has to check criteria whether the dismantler is really certified or accredited, and after that they are, or the trust anchor issues a verifiable credential that says, okay, you are an accredited dismantler, and here is a verifiable credential you can use for access purposes in the Battery Passport system. The stakeholder, the dismantler becomes a holder of this verifiable credentials, and the verification mechanism information has to be stored in a so-called verifiable data registry. This is the central component. When the dismantler wants to access a Battery Passport, he presents the verifiable credential within a verifiable representation. This is just technical. The reason there can be only one credential in, based on this information that the stakeholder group of the dismantler is an accredited dismantler. The gateway or the evaluation component can evaluate the access policies that are available for all the same in one policy rule set, and can decide whether this dismantler can access data in the Battery Passport, and the verification can be done via the publicly available data in the registry. After that, he can say, okay, you are allowed and permitted to see dismantling information, but you are not allowed to see other restricted data that are not allowed to be seen by dismantlers. So closing words to the decentral data spaces, and then I will hand over to my colleague Nico. So we have the requirements. Trust and digital sovereignty among participants is realized. We have access policies for stakeholder groups. This can operate cross-country and cross-company. This is by design in Gaia-X. This has this can be done fast and efficient because it's mostly done by APIs and no manual processes, and it can handle coexisting standards. And we have no siloed single-purpose solutions. To be considered, this whole concept is new. The technology is new. This is known. It's growing, and but it has a strong support from the European Data Strategy and from the Commission. and is supported with lots of funding and lots of to push it in the market. And it has a growing active international community. Ecosystems are needed. For example, you need the trust anchors who are able to check your criteria and to issue the credentials. And of course, it needs, with so many people working together in a data space, IT service governance and security infrastructure needs a little bit more attention, because if there's a breach in, standards have to be maintained, and this has to be obeyed by all the different economic operators, because all of them have to become providers of data themselves or via service providers by the regulation. But going back to the no single purpose solution, this all is effort, but it's not a single purpose effort, because data economy and common data space technology offer many future oriented opportunities and synergies, because you can not only use this for battery passport, but for all different business models or ideas or whatever you plan to do with data spaces. And so it is rising you to a different level and higher level of digitization. And so it's not a single purpose solution. And I think that is what we wanted to achieve. And now I hand it over to my colleague Nico for data models, data granularity, and supply chain due diligence. Thank you.
Yes, thank you, Gernot, and also a warm welcome from myself. I think WIMA, we are stable with about 270 participants. Happy to see the big interest in the work that we done so far. What I'm going to show you now is some insights on the current work in progress on data models, data granularity, and supply chain due diligence. So yeah, first of all, we heard a lot about interoperability and DPP data DPP system. So why is it important to have this interoperability based on common data models? So an important aspect is, of course, that we, though we are working in the Battery Pass project, we are trying to looking ahead for future sector-specific DPPs, as it already mentioned from my previous speakers. So we have in future electronics, textiles, and constructions, and all the DPPs will be handled in the DPP system, and that should be compatible for everybody. And there are also a number of use cases which actually defines that it would be necessary to have this compatibility, given the case that a battery which reaches a state of health below 80%, then it can be reused or repurposed as a storage battery in a house. And in the future, there will be also in the construction area DPPs, so the data from the battery passport will then be entered into the construction or building DPP. So from that perspective, it's very important. It's also important to support different technologies. So this is an important topic that we are trying to address, to have technology agnostic definition of data models. And so what is also important to mention that the regulatory requirements also require that the product passport should be as uniform as possible across product industry sectors. And this is exactly what we intend to do. The Battery Passport is the first digital product passport which is demanded. In the future, there will be others. And we believe that we could create kind of a blueprint for future digital product passports. So now I would like to come to how do we to realize that. So you may be aware of the publication from April 2023, where we published a complete data attribute long list, a list of about 100 data points which are demanded by the European Commission. And those data points are just defined in an Excel sheet. However, for managing in an IT system, and so we as a company, we are heading the work package for the digital product passport demonstrator, the battery passport demonstrator. We are looking at that topic also from an implementation perspective. And so what we need to do is to translate the data point list into a machine readable format. And the way we are doing this is actually by the application of the resource description framework. This is a standardized language, standardized by the W3C organization, which allows to define data models in a very efficient and meaningful way. So there is also the possibility to define a meta model based on RDF, which defines core elements like entities, properties, data types, physical units. So everything what you need in a semantic data model. And based on this elements, we are building for each of the 7 sectors, or the 7 content cluster, we call it content cluster. For the battery passport, we build individual data models. What we also make sure here, and this is something which relates to the fact that we intend to provide a blueprint for future DPPs, these content clusters are completely independent from the product. So this could also be applied to different products like electronics, textiles, or buildings, whatever will come in the future. So this is also an important aspect here. And we also make sure that the data models that we define, they are basically related to the requirements from the battery regulation. So all the data points will be included, but we will allow an architecture which also allows the extension of individual data points, because we also believe it's important to extend the data content of the battery pass, because the battery passport would be also kind of a catalyst for the circular economy and also for general digitalization along value streams. So now, how do we realize this in detail? So first of all, we have a data model. So what we decided first is to take an existing meta model. So this is a model provided by the Eclipse semantic modeling framework, which is public available. I'm sorry. Based on that, we built the independent, platform-independent data models. So here you can see just a fragment of the code of the RDF language, which is derived from the data model, or the data model is described with the RDF language. So here you can see we have here some objects like the properties. So these are the basic elements of the meta model. We have specific characteristics. We have units which are defined here. And this definition of the data model is completely independent from any technical implementation. So to make it specific to a technical implementation, this data model can be transferred into another implementation, into another representation of the data. So this is an example of a JSON schema, which includes in principle the same information, as just a slightly different format. And the idea is actually to also support existing technologies and maybe future coming technologies, to have a flexible way to translate it. And here you will find again the complete definition of the information of the properties, the entities, the units. There are also some enumeration values which are defined here. And based on this, the concrete technical implementation can be based on. And finally, the data then can be transferred through corresponding mechanisms and transport mechanisms. And here we can see then the concrete data, which is then transferred. For this example, we take the product carbon footprint model that we identified in the project. And so you can here transfer the product carbon footprint for 4 different sections of the value stream, and the complete carbon footprint, the link to the carbon footprint study and the performance class, which have to be defined here. So again, to conclude, technology independence is very important, and keep it open, and technology independent is a big point and an important point to make this possible to implement this also in different ways, and also in less time and efforts. So this is a more detailed view. I just would like to give you an overview what we did so far. So this is one of the 7 common data models, in that case for the carbon footprint. So we have here, this is a graphical representation of the model. We see here the different properties. We also include detailed descriptions. So this defines actually the concrete semantics of each data point, which then can be translated. And here is a detail. So this is a data point for the carbon footprint study. The carbon footprint study, of course, will not directly be saved in the Battery Passport, but there will be a resource path which links to the study, which is then represented at the economic operator data repository. So coming to another topic, so we discussed a lot about how does the Battery Passport data relates to life cycle stages and product component levels. So we call this granularity. So the level of granularity or the dimensions of granularity can be differentiated between 2 dimensions. So we have the life cycle stages and we have the product components level. The life cycle stages are actually defined in 4 different stages as specified. So this just includes the technical product characteristics from the specification phase. As designed means the concrete design information. As planned will also include the information of the manufacturing process, which is, for example, important to get more accurate ESG metrics. Then we have the as built, which includes also the clear conditions of the way how the battery is built. And then we have the as used, which is the actually individual battery, which then can be tracked along the further use phase, and additional information can be updated to that. The second dimension are the product components levels. Here we are looking at the closer at the battery, and here we identify the battery pack as the upper level, then the battery module and the battery cell. And so now the question is, while the Battery Passport only relates to the pack level, so this is a decision that we made that the product passport, the Battery Passport, will be related to the pack level. We shouldn't disregard the other levels. So the idea is to have the Battery Passport at the pack level, but to include the information from the module, especially from the module item, because it could happen during the lifetime of the battery. The module can be exchanged. This led to an update of the Battery Passport, and this should be done really on the module level. On the cell level, only the model is relevant for the information. Usually, or in most cases, there's only one cell model in a whole battery, but there could be also different cell models in the future in the battery, and only on the cell model level, the information like the internal resistance and of course the composition of the material, which is mainly located in the cell, will be also managed in the Battery Passport. And why is it important to have this distinction? So an important requirement from the battery regulation and also from the ESPR is to allow consumers make informed purchase decisions. And this can only be done if this information of the battery, like the performance of the battery, and of course the ESG performance, like the carbon footprint, and also the responsible sourcing of the material in the battery, is defined prior to the build process. And so this is then put into the Battery Pass model. And the detailing and the distinction between these different models is then a proposal from our side. So how to select the right Battery Passport along the different life cycle stages. So again, as the Battery Passport is needed for the informed buying decision, first of all, it has to be checked on which life cycle stage the battery passport has to be issued. So first of all, the question is the battery produced? If this is not the fact, the question is it already configured? So is it already clear which components are put into the battery? And if this is not the case, then the information will then be issued just as a model passport, which just include the technical specification of the battery. If the battery is already planned by production, this would allow a more detailed information about the carbon footprint, because if the information is clear and at which plant and with which processes the battery will be produced, allows a much more accurate definition of the carbon footprint, for example, in the battery. And at the end, the question is it a serialized battery? If the question is no, only a batch passport will be issued. The disadvantage of a batch passport is, of course, it does not allow to track an individual battery because a batch passport does not have an individual serial number. If the battery is produced serialized, which would be probably the case in most cases, then an item passport can be issued, which can be tracked also along the use phase of the battery. So concerning data storage and persistence, we identified some guiding principles for the implementation and for the technical means. So one important guiding principle you heard before from the slides from my previous speakers is actually the support of distributed storage. The idea is not to transfer unnecessarily data via the internet, because that would use additional energy, and with that also would also create an additional carbon footprint. So keeping the data where it is produced and just access it in a very efficient way. Another concept for that is actually to use the linked data concept. So in the battery passport, you won't find any rich data elements, only alphanumeric data and hyperlinks will be maintained in the battery passport, so that the rich data elements maintain mainly at the economic operator, at the data repository there, but will be accessible through the battery passport with a mechanism which Gernot explained before. For performance reasons, of course, local caching can be applied, but in general, it shall be avoided to use energy-intensive additional data transfer and storage, and this is one of the guiding principles that we are following to make sure that we meet also the requirements to make it also a sustainable software solution. So management of battery data, of dynamic data in the battery is a crucial point, because when you look at the value chain when the battery passport is issued, the idea is to gather additional information, mainly in the area of performance and durability from the battery. And this is a clear demand from the battery regulation. So they demand that the dynamic data, this is the data which changes over time, like state of health or other information, should be updated, should be up to date. It's not clearly defined what up to dates mean, but at least daily is also mentioned there. And we see this a bit critical, because that would need a direct connectivity of the battery to the battery passport backend system, which is currently not realistic for many batteries. There will be batteries which maybe comply with this requirement, like batteries in EVs. So many EVs are connected to the internet, and so data can be updated. But storage solutions, especially for houses and also industrial batteries, are not necessarily directly connected. And so as a consequence, so the data attributes need also an associated timestamp. So this is not directly required, but we clearly recommend that, because that gives the user of the battery, if he accesses the battery passport, the idea how up to date is my data, and then a recommendation to the economic operator: he should provide corresponding means to update not connected batteries, so that the user can take measures to maybe go to a service point or maybe a charging point for certain batteries, or even a BMS reader app, which allows to support or to read out the BMS and transfer the data to the battery passport. But it's important to mention that those data will not be directly fed into the battery passport. All the data should go through the economic operator, because the economic operator has a responsibility and he has to ensure that the data is correct and up to date. And so all this information will go through the economic operator. So coming to my last topic, this is the topic of supply chain due diligence. So you saw this graphic before. So though the battery pass will only be issued at this station of, you can see my pointer at the OEM. So the OEM or the economic operator will issue a battery passport. There is a lot of happening before. So all the information in the upstream value chain, many information have to be gathered. So some information is of course information concerning recycled content. There's information concerning the carbon footprint, which have to be gathered. And the way to gather this information, so there is a recommendation in the battery regulation to apply traceability solutions for it. So again, so there are different possibilities to do that. So either you can go step by step, but then you have to rely on the information which are provided, and usually in our experience that could be critical. So it would be beneficial if you would directly be able to access this information along the supply chain. The critical thing is, and this is what we would recommend here, is actually to use a traceability system. So this is something where we have experience, and we would recommend to use this, because this would allow the OEM, who usually does not know its complete supply chain, to dig through the whole supply chain and to get access to all the data. And the important point is, and this relates to the responsibility of the economic operator, to make sure that the data is reliable, accurate, and correct in the battery passport. So this has to be ensured. And this can be assured with those type of systems where information on a very low granularity level on materials will be gathered. And those informations can be cross-checked to make sure that the information is correct. Relevant information on supplier credentials and certifications can be applied. There are other mechanisms which ensure that at each data point which is gathered, a digital fingerprint will be created and managed in a distributed ledger. So this would allow that subsequent modifications of those data wouldn't be possible. And so this is an important aspect which we are still discussing in the consortium, and where we see a lot of potential to meet the requirements of the battery regulation. If you follow this corresponding technology, which we are also testing in the project. So we are Circular. We are responsible for the battery passport demonstrator, and we will also showcase how to connect to those systems and to demonstrate how to gather those data from the upstream value chain, which is very important for the battery passport. And yeah, with that, I would close slightly ahead my presentation and give Thomas the remaining 15 minutes for his slides. Thank you for your interest and your attention.
So thank you so much, Nico. Now we come to the final step, and this is going how you can participate to the next development steps and the standardization, as we are aiming here for the technical standards. And there are several opportunities. So on the one hand, we had already in the chat the question, oh, how I can provide use cases. And it's quite easy. You can just send to the emails we will provide at the end your use cases, your requests, so we can have a look how to integrate this into our technical guidance, which will be finalized in spring next year. As well, we are very much keen to the contradictions you have found, for instance. So we discussed this already in the chat. So we will take the considerations from the chat into our thoughts and into our definitions in the technical guidance. On the other hand, yes, the battery passport issues and the entire DPP are very much related to regulation. And this regulation is supported by international, here means European standardization. And this means you can engage into this standardization activities. This can be done by establishing a link from your associations, industrial associations, for instance, to the national standardization bodies, or by a direct engagement in the national standardization bodies so that you can contribute to developing the harmonized standards. I will go in more detail to that. On the other hand, Patrick explained already, the battery passport will become mandatory in beginning of 2027. There's not any more, very much time. So, and as much as possible, you can prepare even your an economic operator, means a producer of a battery, or you are part of the supply chain. You can just start now. This means you can check which kind of data you have available and in which kind of format. So by taking our battery pass content guidance, you can directly check which kind of data you have and which not, so you can prepare. Our technical guidance, as I explained, will come out in the spring next year. There you can see, okay, which kind of technologies you should have in place to provide this data and to exchange. And in the next point, and Nico had explained, the most of the effort will be done in collecting and transferring data among the supply chain from the mine to the production of the battery. And this is not part of the regulation and even not part of the technical standards of the battery passport. But there exist, for instance, specifications coming from the Global Battery Alliance, which can be taken to take into account how to realize these efforts and to establish the right interoperability capabilities. And last but not least, yes, you can drive your thoughts and your interests into communities and associations. Here we listed some of them, like the Surface project, as was as well already mentioned in the chat. The same is for Catena-X, as a very large lighthouse project, and is dealing as well with battery passport data and battery passport systems. We have the Global Battery Alliance, where at least major companies and associations are already engaged, where, for instance, battery producers and providers like CATL or Varta as well, large automotive industry, industrial partners and so on, where initiatives like MOBI or the industry associations like the Z4IE in Germany, where you can really engage and drive the progress. And of course, in order to keep informed, You can go to fairs. So we have the upcoming Hannover Industry Fair in 2024, sorry, where the Battery Pass project will perform the demonstration how interoperable standards can be achieved at the Fraunhofer booth. We are planning to participate to different conferences like the Battery Expert Forum in November 2023, or from the research perspective, the Interoperability IESA conference in April 2024. And in our LinkedIn account of the Battery Passport project, you get as well the news about our progress. Now coming to the standardization progress and process. As Patrick already explained, we expect to have the final standardization request now in October 2023. And then this has to be adopted by Censenelec and ETSI. There is a plan to implement these standards by Censenelec by having this joint technical committee number 24. And there will be the kickoff at 18th of December this year, just before Christmas. So we can start in January to develop at least the harmonized standards, which will become responsible to implement the regulation. And you see the timing. We do have just the time until end of 2025 to provide these harmonized standards. Patrick explained already some of the chapters. Today, we went into more detail to the data processing, data exchange protocols and data formats. We went into the access right management and by Gernot, for instance, or the data authentication, reliability and integrity, and some parts of the interoperability. So today, we had no time to go in detail to the unique identifiers and the data carriers, as well as the data storage, and the services as has to be defined by the APIs. This will be covered in the technical guidance, and we will demonstrate this at Hannover Fair in April 2024. So how to contribute into the standards? It's quite easy. Every member state has its own national standardization bodies, where at least committees are created, are under creation. And in Germany, we have this DIN DKE committee on the DPP system, where we had this kickoff meeting in July. And the next meeting is at the 10th of November to prepare the kickoff meeting of the JTC. And then a delegation from these committees are responsible to work in the JTC 24. The secretariat is adopted by the DIN, the German Organization for Standardization. And then there will be established several working groups. For instance, can be happen to have a systems architecture group or a group for unique identifiers. There's a possibility that you can contribute to that on the standardization perspective. And now we come to our last step, how you can perform feedback. And this means you will receive an email where we provide an extended version of this slide deck as we provided today. There will be some further details. We had no time today. There will be as well an Excel document where you can as well have some questions on the presented challenges, so you can contribute on that. And in next spring, we will provide the final version of the technical guidance. Now we are in a version 0.5. So most of the content is already there, and now this will be step by step refined and improved. And so we are very much keen that you can provide additional insights and thoughts so we can consider this in this document. And this means you can have a look on our website. You can subscribe to our newsletter or following to the LinkedIn. And based on the email you will receive very much near in the future, you can send back as well your thoughts. So thank you so much for the audience. Now we had more or less 270, 240 participants in our webinar. Thank you so much as well for contributing so heavily in the chat. We tried to answer to this question as well. And we wish you a nice day and of course more intensive in the relationships in the future. Thank you so much. Bye.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Thank you for participation. Appreciate it.